An electron falls from the rest through the vertical distance of h in a uniform and vertically upwards directed electric field E. The direction of electric field is now reversed, keeping its magnitude and the same. A proton is allowed to fall from the rest in it through the same vertical distance. The time fall of the electron is in comparison to the fall of proton is. Okay, so here we have two electrons falling from the rest of the vertical distance h and with a uniform and vertically upwards in a direction magnetic field. One is electron, that is negative one, and one is proton. So these two are falling from the rest of the positions. So we need to find the time of fall of electron in comparison to the time of fall of proton. So there is a simple formula for this, that is h equals 1 E, that is electron, and this is the electric field, capital E, 2 m, that is the distance, meters, and t square, that is time. And from this we can say that t equals under root 2h m upon E with the capital E, that is the electric field. This position is equal to m. So from this we can say that T is directly proportional to m as E for the same electron and proton. Since electrons have smaller masses, so it will take less time than proton. The proton masses are bigger than electrons, so obviously we have asked for the electrons. So in comparison to the time fall of the proton, the electron will take less time, that is smaller, not equal. The smaller time, it will take smaller time than proton.